Welcome back, everyone. Today we are going to be transforming complex numbers into trigonometric polar form. So let's dive in. All right, so in general, the formulas for polar form for complex numbers are going to be that z is equal to r times cos theta plus I sine theta. So that's a very key equation that we'll be using throughout this. Also, r, the radius, can be calculated by finding the magnitude of z, which is equal to the square root of a squared plus b squared, where basically the complex number, whatever complex number we're doing, is going to be written in a plus bi form. So that's what we mean by a and by b, is just what is the constant and also what number is being multiplied by I, right? By our imaginary component here. And so we also know that theta is equal to tan inverse of b over a. All right, so let's dive into this first one. So in this first one, a is equal to 6 and b is equal to 5. And so let's first compute r. r is going to be equal to the square root of 6 squared plus 5 squared, which is equal to the square root of 36 plus 25, which is equal to the square root of 61. Okay, now we're going to compute theta. And so theta is going to be equal to tan inverse 5 over 6. And that's going to be about 0.694 radians. And so therefore, the final answer is that z is equal to the square root 61 times cosine of 0.694 plus I sine 0.694. Or if we were ever just looking for the coordinates, right, for what is r and what is theta, that would just be root 61, comma 0.694. All right, let's do the same thing with the second example. Here we have negative 4i minus 3. So in this case, a is equal to negative 3 and b is equal to negative 4. So let's first compute r, the radius. R is going to be equal to the square root of negative 3 squared plus negative 4 squared, which is going to be the square root of 9 plus 16, which is the square root of 25, which is 5. And again, actually something I should mention here, because we're looking for a radius, we're only considering the positive versions of these square roots. So it's not plus or minus 5 here, it would just be 5 in this situation. Then we have theta, which is going to be tan inverse of negative 4 over negative 3, which is going to be tan inverse of 4 over 3, which is going to be 4.068 radians. So therefore, z is equal to 5 cosine 4.068 plus I sine 4.068, like that. All right, if there's any questions, please let me know down in the comment section, and we'll see you for the next one.